Hello everyone, welcome back to another SL/HL video. Today we're going to be looking at fossil fuels and their formation, as well as their relative advantages and disadvantages. So let's write out the names of our three fuels over here and create a nice little table to compare them. Okay, so let's start at the top with the formation of coal. So coal consists of carbon, hydrogen, nitrogen, and sulfur as elements, and these in the form of peat will undergo high pressure and temperature to turn into lignite. This will then undergo even higher pressures, even more temperature to turn into bituminous soft coal, similar to bitumen, which you get in your fractioning cylinders, but not quite the same. And then this will go or undergo, yet again, even higher pressures, even higher temperatures to result in anthracite, which is just the fancy name for what we call coal. Now, one thing to know is that throughout this process, the percentage of carbon atoms increases, and it is to the point where once we get to anthracite, or our end product being coal, we have about 80 to 90% of the sedimentary rock consisting of carbon. Next up, let's look at oil, or crude oil. Same thing in this case. For crude oil to form, marine organisms, so let's write that down, marine organisms will die. And these organisms will then build up a layer of sediment over organic layers on the very bottom of the ocean, or aqueous bodies, large ones. As they're at the bottom and more layers will build up over them, we will get higher pressures. And between these layers of sediment, which will build up over time, we will find that there is biochemical activity. And what happens here is that under these high pressures and with the help of these organisms or bacteria or whichever decomposers which are present in these layers of sediment, they will help break down the organic matter into crude oil. This oil will then migrate through rocks thanks to the help of geological movement, so movement of tectonic plates, whatever it may be, and these will then collect in traps. And as the name suggests, a trap will be a reservoir in which the oil can no longer move around. And just so that we know, fun fact, crude oil tends to consist of mainly alkanes, so you don't tend to see a lot of alkenes in your crude oil, so alkane. And these can consist of straight or branched chains. They can be cyclical or aromatic as well, which is just when they are present in benzene rings, such as this, when the carbons arrange themselves in benzene rings, such as that one. Finally, look at the formation of natural gas. So the formation of natural gas is quite similar to that of crude oil, in which compression and high temperature, so high pressures and high temperatures, cause carbon bonds in organic matter from dead plants or dead animals to break down, forming methane. plant and animal. So let's look at the evaluation of each form of fuel. So advantages of coal. Well, coal is globally abundant, meaning that it is available worldwide. And this can serve as feedstock for organic chemicals. Now, feedstock is a word that I'll be using a few times when looking at advantages and disadvantages. And feedstock is essentially when you have a chemical which can serve as a raw supply to fuel a machine or an industrial process. So essentially it's the fuel for a processing plant. And coal, as is, can be used as a feedstock straight away without needing further processing. Next up, coal has a vast energy potential, and it is also safer than nuclear power. But in terms of a vast energy potential, an energy potential in a fuel means the stored energy in an object. So high stored energy. In this case, it's due to its chemical bonds and its high percentage of carbon, as it is a sedimentary rock composed of primarily hydrocarbons or carbon. And finally, as it is a solid, it will be the most stable of the three, meaning that it has the longest lifespan. So safer than nuclear power. And oh yes, another advantage of coal is that it can also be easily converted to synthesize liquid fuels or gaseous fuels, whereas the reverse is far harder to do. But let's look at the disadvantages of using coal as a fuel. So due to its nitrogen and sulfur impurities, this can oftentimes, its combustion can lead to acid rain, as nitrogen and sulfur react with the oxygen in the air. So let's write that down, acid rain. Next up, as we know, combustion of any hydrocarbon will result in carbon dioxide in the atmosphere, leading to global warming. We'll look a little bit more into detail into this after our comparison. Coal is harder to transport than, say, oil or gas, because it cannot be transported through a pipeline. Next up, coal also oftentimes will lead to slag heaps. Now, slag heaps refer to the waste or the leftover after coal undergoes combustion, which is often disposed of as just mountains upon mountains upon mountains of slag. And these will be massive. These do not easily decompose over time. And obviously this kind of pollution is not the best for the environment because it's not easy to dispose. Next up, the mining of coal is dangerous because oftentimes in coal mines, you may hit pockets of, for example, natural gas that you can't detect because it tends to be odorless and colorless. And what will happen is that whilst mining, if you hit something a little too hard, you'll form a spark. This spark is sufficient to overcome the gas's activation energy, leading to a big explosion, which just blows up the whole mine, which is obviously not very good for the workers working in it. So not very safe, not safe at all. And last up, as we know, carbon monoxide, carbon dioxide, and just carbon soot. These are pollutants, they form smoke, and these particulates are very dangerous to the respiratory system, as they can be quite corrosive to the very thin and delicate alveoli present in your lungs, as well as irreversibly binding to hemoglobin, so that you are basically unable to properly oxygenate your blood and you die. So next up, let's look at the advantages of using oil. So oil, as we mentioned, is very easy to transport, as it can be transported in pipelines. It's also a convenient fuel for this same reason. And oil can also be used as a feedstock, just like coal. But the disadvantages of using oil is that you will yet again get acid rain and global warming. It has a more limited lifespan, as it is a liquid and not a solid like coal, and it is not evenly distributed around the world, leading to a lot of competition surrounding this fuel. And the transportation of oil itself, although convenient, oftentimes leads to a lot of pollution in and of itself, as your tankers or your boats will be burning their own fuels, releasing their own load of carbon dioxide into the atmosphere, just to get the oil to where it is wanted due to this uneven global distribution. And lastly, we have natural gas. So unlike coal and oil, this is considered a clean fuel. And this is because its combustion will not result in the formation of acids, which will then rain back down on Earth, so you don't get acid rain from this. It's also easy to transport, just like coal, because it's a gas, it can just go through a pipeline. As we mentioned, no acid rain, and of the three, it has the highest energy to weight ratio than the other two, but it is still a hydrocarbon fuel, and this means that you will still get global warming. As it's a gas, it also has a limited lifespan, as it's not exactly inert. And as you mentioned earlier, we have a very high explosion risk associated with this gas, due to how easy it is to overcome its activation energy. Now looking at atmospheric, so let's draw a cloud representing the atmosphere, atmospheric CO2. So over the last 60 years, the amount of atmospheric CO2 has risen up to 30%. And as we know, carbon dioxide is a greenhouse gas. Now, we've all heard of these greenhouse gases, but let's just do a quick little recap on what they do. So let's give the Earth a nice little blanket, nice and warm, called our atmosphere. That's the Earth. Let's draw some. There you go. So high energy radiation from the sun will pass through the atmosphere down to the earth. As we know, this will then reflect back up into the atmosphere. And supposedly, the atmosphere, its job is actually to absorb some of this radiation to keep the world warm enough so that we can actually exist and life can actually be sustained on this planet. But what happens when you have an excessive amount of these greenhouse gases, such as carbon dioxide, is that they will absorb the low energy radiation. So, got the high energy, then the low energy. And the low energy radiation will be absorbed by the atmosphere, not allowed to reflect back into the universe, which leads to a excessive increase in temperature. Now that is all for this video. Thank you for watching, and I hope that this was helpful.